Hello, fourth grade scientists. I'm hoping that you've already watched my review video on electricity and circuits. And now we're going to take what we know a step further. We're going to actually test some objects to see if they conduct electricity. So we're starting right now. We have this circuit that I built in the last video, and we see that the bulb is lit, and the bulb is lit because the circuit's closed. What I'm going to do is I'm going to actually open my circuit up. I could do that any number of ways, but I'm just going to disconnect this, okay? So, in order to test things to see if they will conduct electricity, I'm not going to change much, but I'm just going to add a wire, okay? So, everything is basically set up the same way. We have the battery, the power source. We have the light bulb, which needs the power. And now we just have an extra wire in here, okay? So, it's just a little bit bigger and a little bit harder to fit on my platform here. So, all we have to do to close the circuit is we have our two metal alligator clips. We press them together and the light bulb lights because now the circuit is closed, okay? So, whereas before we were opening the circuit over here, all we're doing now is we're opening the circuit over here. Closed. Oh my God, everything's coming apart. Okay. Closed, open, closed, open. Okay, so what I'm going to do is I'm going to put various objects in between these two alligator clips, right? So we know when we close the alligator clips, when we touch them together, the circuit closes. So it would stand to reason that anything that conducts electricity, if we clip it in here, it will keep that electricity flowing. It becomes part of the circuit. So we know that the only material that conducts electricity is metal. So we would predict that anything made of metal will complete the circuit and will allow the electricity to flow and will light the bulb. We can also predict that something that's not made of metal, although it may look like a circle, when the electricity comes here, let's do an actual example. I'm going to take a piece of wood, and I think we can all agree that wood does not conduct electricity. So, things are falling all over the place. Okay. So this closes the circuit, right? You can see the light bulb right over here, okay? Metal to metal closes the circuit. So if we now take something that's wood and we put it in between these two clips, this now looks like a closed circuit because we don't see any gaps or holes in the circuit, but the light bulb is not lit because what's happening is this is made out of a material that doesn't conduct electricity. So the electricity comes out of the battery, it travels through the wire, but then when it comes to the end of this metal clip, it doesn't have more metal to continue to travel. So this is almost like that example I did in class where I was an electron walking around and the floor opened up and there was a big hole. And I, the electron, had to stop because I had no way of continuing. My circuit opened up. So that's basically the same thing. As soon as we get to the end of this metal, the circuit is opening up because it's almost like there's nothing there. There's no way for the electricity to continue to travel. So we would predict that wood does not conduct electricity, and we are correct. All right, what else we got? A piece of plastic. I think we can also agree that this will not conduct electricity because plastic's not metal, right? Okay, so we're going to try the same thing. We see that the circuit is open because the bulb is not lit. Closed, open. So we're going to take this piece of plastic, we're going to put it in as part of the circuit, and once again, our prediction is correct. This is not allowing the electricity to flow because there's now basically a hole between this metal, and the electricity has to stop. It has nowhere to go. Okay, seashell, also not metal. Put it in our circuit. Wah, wah, nothing happens. no lit bulb because the circuit is not closed, okay? I think you get the point. So now what we're gonna do is we're gonna move on to some metal objects, and I think we can agree that we're gonna expect that all the metal objects, when we put them in the circuit, they're gonna light the bulb because they're gonna close the circuit. So paperclip, check. See how that lit up? Now when the electricity gets to the end of this clip, it can continue flowing because it's going right into the metal paperclip and then right into the metal second clip through the wire and down to the bulb, okay? So now we're gonna open the circuit back up. We're gonna try a different metal object. A screw. Let's see. And it's actually too fat for me to like put this alligator clip on, so I'm just gonna touch it. See how the bulb lit up? I closed the circuit because I put a metal object in as part of the circuit. Okay, so that all makes sense. What I want to do now is I want to tie this to magnetism. So if we think back to when we worked with magnets, we learned that magnets are not going to attract things that aren't metal, right? If I take this plastic lid, it's clearly not attracted to the magnet. And remember, the magnets have the two poles, right? The North Pole and the South Pole. Those don't matter when we're looking to see what is attracted to a magnet. Either end will work. If something's attracted to a magnet, it's going to be attracted to the North Pole or the South Pole. It doesn't matter, okay? So this plastic piece, it didn't conduct electricity, nor was it attracted to the magnet. Why? Because it's not metal, right? Makes total sense. We would expect the same thing of any of these non-metal objects. None of them are going to be attracted to the magnet, just like they were not conductors of electricity. Same thing with the shell. I don't want to throw this one over my shoulder because it's a lovely natural thing, so we're going to just nicely put it over there. Now let's look at the metal objects, because although all of the metal objects did close the circuit and did conduct electricity, we're going to test them now with a magnet, because there is a little bit of a difference, because not every kind of metal is attracted to a magnet, okay? So we're going to start with the paper clip, and we've worked enough with paper clips that you should know that it will be attracted to the magnet, okay? So this is attracted to the magnet, and it also conducted the circuit, completed the circuit, okay? Bye. The screw. Now we saw that the screw did complete the circuit, it lit the bulb. It also is attracted to the magnet. Fabulous. Whoops. Boys and girls, don't throw things at home. So now we have a penny. So we didn't try this one in the circuit yet. Let's give that a whirl, shall we? Okay, so we're going to put the penny in between the two clips, and we will predict that because it's made out of metal, it is going to close the circuit. I don't know if you're able to see, but yes, it did close the circuit. So the penny, because it's made out of metal, and you'll notice that when I put the clips...
Class teachers, if anyone is in need of assistance, please let me know so that we can get some help up to you, whether it's packaging stuff to put in your envelopes, labeling your envelopes. Please give me a call or text me so we can get people to the rooms to help you. Thank you.
We're all hard at work here at PS 160 to bring you remote learning, people. Okay, so it's very important that when we put the objects in between these clips, the metal part on the clips does not touch, right? Because if the metal on the clips touches, we don't know if that's what's lighting up the bulb or if the object between the clips is lighting up the bulb. So we have to make sure that they are not touching. So we put them on two different ends, okay. But the bulb is lit, So the penny, because it's made out of metal, it is attracting electricity, okay? It conducts electricity because it's metal. Let's get this out of the circuit. We're opening the circuit back up. Now, we want to see if the penny is attracted to the magnet as well. It is not. So the penny, although it's made out of metal and it does conduct electricity, is not attracted to the magnet, okay? So the basic idea here is we can predict that anything made of metal will conduct electricity. Anything made of metal may or may not be attracted to a magnet depending on what kind of metal it is, okay? So that's how we test for magnetism. And this is how we test. Remember, we don't want the clips to touch. To see if an item will conduct electricity.